Hello all, welcome back to the course. This particular lecture is on map display and visualization. This is in terms of how do we actually look at the maps, what are the ways that we have to use certain visualization techniques. When I say visualization techniques, these are the symbols that we use in the maps. What kind of symbols that we use, how we use it, what are different styles that are there for representing different quantities, what are the different measures that we use. So all of these things that we would learn in this particular lecture. So now we are actually graduating in terms of looking at how the practical aspects can be looked at from the real world perspective. So please be careful in understanding each and every aspect, so that when you are actually doing it on practice, it may be very easy for you to understand at a one go. Okay, so as I said, in the concepts that we would cover in this particular class is on visualization process in GIS, the information transformation, how we transform information into conveyable images, then look at maps and cartography, then map graphic symbols, what are the symbols that you use for different types of maps, then how do we select, or are there certain styles that through which you select your map symbols. Okay, so we would look at all of these aspects when we go on in understanding different parts. The first thing is visualization. So whenever I speak about visualization, most of them assume that I am trying to give some picture of maybe the model picture of 2030, 2040 or 2050. So that the visualization doesn't just mean that. Visualization means that whatever you are trying to communicate visually, okay, it may be in any other way, you are trying to put in symbols, you are putting in text, you are putting it in colors. So how you are trying to convey the most complex phenomena in the most simplest languages, that is what it means by visualization. So visualization also means that very complex phenomena is put in a simpler way in most interactive graphics. Okay, it can be even interactive text. So but it has to be extremely useful. Just with a one go, people will understand what are different graphics. So that is what it means by visualization. And in GIS, the final portion of it, when you deliver the data, when you show the data, when you are actually putting out the data, the thing that actually matters is how you have visualized your entire data set. It doesn't matter how you have created your data, how you have done, but once you have some meaningful information, the final thing that people would look at from you is visualization. If you can put them in the most communicable way, then it is the best practice that you have followed. Okay, so GIS is very effective in terms of visualizing geospatial data. So I am very specific, it's not data, it's geospatial data with the with any greater details that you may have. The map user can locate geographic objects, while the shape and color of signs and symbols representing the objects inform them about the characteristics. So here you should understand these aspects. A map user can locate geographic objects, okay, bar entities. Okay, now these entities would have certain shape, certain color of, where it will be represented in a form of a sign, bar shape. Okay, these are representing the information to the user, the signs. For example, you would have seen your the Google map, right? So when you look at your Google map, let's say if you are trying to look at where is your airport, okay, if it is representing something like this, okay, this is where your airport is, it refers to you by a symbol something like this. So it is referring to an airport. Okay, so it is actually telling you that that is the place where the airport is there. So that is what is a characteristic of a GIS. Okay, the queryable map reveals the spatial relationships, the patterns, and offers an insight in and overview of distributions of a particular phenomena. Now, so when you are looking at visualization, you are looking at in the form of a data to display. Okay, you take in data, you use the data and then display the data. Okay, when you are normally visualizing any of the geographical data, it is very important that you should understand there are series of fundamentally different types of data. Okay, it is not that only one data that you use. As I said, you can have a raster data. For example, whatever I have given here, you have a two sets of raster data here. This is a land use data and this is a slope data that you have, and this is a hill shade map that you have. But this is the map that has contains the number of polygons and points. There is again a raster map here and there is again a raster map. So it is a collection of fundamentally different kinds of maps that are put together that has to be handled in a different way. The relationship that handles here is very different. The way that you handle the land use map is very different from the way you handle your slope map, or where you handle your hill shade map or the vector map. Each has a specific way of handling it. If you are trying to handle it everything with the same function, then probably the error will again creep in. Okay, when geographical data is actually represented by the point line and polygons, also there is also a raster. That's what I mean in terms of geographical data in maps. Okay, now when we look at the visualization process, as I had previously said, it is how you want to present your data. Okay, it may be in terms of symbols, it may be in terms of colors, it may be in terms of the way maybe certain processes are or the phenomena occurs. Okay, it is, you have to look at what is the motive of or the intent of your application. Okay, not every application you use the same color set, same way of representation. What is the motive of that particular application? The first thing you have to analyze that first, then select what kind of symbols you need. So if you understand the motive, the aim, the intent or the goal of that particular map that you are generating, see, let's say that I have 100 or 150 data sets. It doesn't mean that I create 150 maps and just put it in front of you showing that I have created all of these maps. But what is the use of these maps? The intent of any application is applicable only when you have certain useful maps. Now if I am trying to look at how the urbanization process has happened in Kolkata, why do I have to show every map that is from the drainage network to your rainfall to your urban data to or your vegetative features, etc. Instead, if I can represent how the change of the urban area has happened from 90s to 2000s to 2010 on till 2019, that is favorable enough for anyone to understand how the urban growth has happened. That is exactly what I mean. You have to understand the motive, aim, intent and the goal of a map. Why are you preparing that particular map? Then what data is available for the composition of a map? What kind of data that is there for composition in a map? So that you have to understand whether the data that you are using is extremely useful to compose a map or not. Okay, then what resources are available in terms of both time and equipment. Okay, so this may not be a real challenge in today's scenario, especially where you have high computing capability, but where there are no high computing capability, especially in rural parts, then it may this may pose a serious issue. How well does map communicate to your audience? So I have to give some message to my audience who are actually the consumers of the map that I have actually created. Okay, so to convey every detail of that particular map, I have to put it in a proper shape. If I am representing a street, I have to represent in a better way. If I am representing a house, I am representing it in a way that it is more communicable, maybe a house symbol. As I said, if I am representing an airport, then an airport symbol should be there. So the way that I want to communicate, so if such symbols are there, it is easier for every audience to understand. If I am trying to look at the academic audience who understands every aspect of this particular maybe the research aspect, so I don't need to put them in every aspect. So I don't need to communicate to them as what is airport, what is house, but I need to communicate to them on what is the output of whatever I have done over for as far as urbanization is concerned. So that is where the intent and what is required for audience will meet in two different contexts. Okay, then your who will read your map, who will use your map. So that is another very interesting thing. If you have to first think who will actually consume or use your map for any purpose, and for what applications. So if in such cases only you will be able to look at the map intent. Then where will be the map be used, whether the map is used for certain purposes, certain issues, or certain looking at certain phenomena, or you for some just for a visualization purpose. So based on that you will look at what kind of visualization you need. So all of these has to be thought about when you are visualizing it. Don't just put, so you have some tool to visualize it, just put some values, some color, some text and leave it. So but please look at all of these aspects, then only you will be able to visualize your GIS data properly. Extremely well represented GIS data gives you a lot of information. Also the audience would like it because it would give the depth of knowledge in terms of what they are looking at. Okay, so if I go back to my the first session, so I spoke about the information transformation, that is from the real world to the map image or to the end user. We started with the real world. We looked at the geographic environment where you have the real world associated with the environmental data. Then you have a geospatial data, that is spatial data along with the data model. So once you have captured the entire data model and you have worked on it, you have done the editing and any other analysis using certain tools and signs, then you create a map. Okay, the map is then presented to the end user as a map image. Now I have transformed this entire process in a bit different way, so that you understand. Now since we are graduating towards how we actually represent a map, a real word in terms of the data model, we are I'm trying to graduate the entire aspects that what we have thought into an image resource that can be used by the end user. So we looked at data capture and models, we looked at data collection and processing. Next is the selecting, symbolization and generalization, and finally it is analysis and representation. That is what we are learning now. Okay, so now people would have heard about cartography. Okay, cartography is actually a science of making and study of a maps, or making of a maps, or even a study of maps in all their aspects. That is nothing but called as a cartography. It is art or science of making and study of a map in all aspects of what that maps gives information about. So aims of cartography is to achieve an intuitive recognition and understanding of one or messages in a map, in a particular map that is we are trying to use. Cartographers classify maps into a general reference or based on thematic reference. Now the cartographic maps are based on thematic references, and qualitative and quantitative. Okay, so you can have qualitative maps also, you can have a quantitative maps also. That is based on the requirement that you have and the end user who is trying to use your maps. And to display a spatial feature on a map symbol is used to indicate the feature, location and a visual variable, that you should remember. Then symbols are often used to show the feature attribute data. Okay, now I am trying to connect with the spatial data to an attribute data. If you want to represent an attribute data, then you show it in terms of symbols. Okay, so when we look at map graphic symbols, these are visualization that is for human ability to understand in terms of pattern, context and differences. So if you want to understand in terms of pattern, context and differences, then you use map graphic symbols. So Jacques Burton systematically classified the use of visual elements to display data and relationships into parameters. So he explained how we can look at the visual elements and display any of those geospatial data that we would have generated in terms of relationships and in different parameters. he basically took it into 6 parameters. The basic parameters that he looked at is size, shape, color, color hue, color value, color saturation, hue, intensity, saturation. This is basically the way you look at your information in your data. So size, shape, color hue, color value, color saturation, and orientation. So these are the 6 different parameters that he classified where you can use your map graphic symbols for effective representation. So this is mainly used to symbolize geographic phenomena of points, lines, and polygons. 6 variables, they differ in their application and can illustrate quantitative or qualitative characteristics in terms of representation. Okay, so when we look at map graphic symbols, for example, if you have a size, so it can be something like this, it can be something like this. For example, you would have seen the population map of the globe. The bigger the size of the symbol shows you the bigger the population, the smaller size will show you the smaller the population. Or you would have seen the urbanization. If you have not seen, please type in the urbanization across the globe. You will see very good graphics in terms of which area has the huge urban growth, which is having the least urban growth. The graphics will give you an estimation of where the urban growth is happening and where it is not happening. That this is in terms of points, this is in terms of lines, and as far as areas is concerned, it is how it is actually normally not recommended. When you look at shape, it is appearance or form of a symbol. Okay, for example, these are different symbols used for different purposes. I gave an example of usage of airport symbol, usage of road symbol. So these are some examples. We normally use shapes in terms of representation of points and not for lines and polygons. When you look at color hue, these are dominant wavelength of light in the visible selection of electromagnetic spectrum. So for different processes we use different colors. Maybe if we are looking at danger, we use a red, green. Red, blue, green is the common color palette that is normally used. For example, if you want to indicate danger versus not dangerous, so you can look at these symbols, and these are for the similarly lines also can be represented, and even the areas or the polygons. So you have color values which are light or dark variations of the single hue. Okay, maybe the density is less, the density is more. Population density which is more versus population density that is less. More means it is darker, less means it is lighter. So similarly it can be applied for both lines and polygon, but normally very well used in terms of points. Color saturation, where intensity which or purity of a single hue. Okay, so this is what is for color saturation. It can be used for all the 3 phenomena or all the 3 vector point, line, and polygon. And orientation, so these also are quite important in terms, for example, if you are looking at the water flow, if you are looking at the slope aspect, the ratio, etc. So you need to look at the directions or angle of rotation of for the entire map. So that to represent that, you use something called as orientation. That is very good in representation of a point, but it is not recommended in representation of line, whereas in areas it is very well established ways of looking at this particular symbol, graphic symbol. So this graphic symbol, I'll go on with every symbol. The map graphic symbol for size. So this if you see on your right hand side, you see a graphic symbol that is actually representing the graduated population. For example, this symbol is representing the population for every ward. These black lines are representing ward. If you are I can just zoom in so that every one of you have a look at this particular map. When you look at this particular map, see these black lines that you see here are nothing but your ward sections, and these big circles represent higher population. Small circle represents the lower population. This is a population data of 1991. You can see that central area of Bangalore has very high population when compared to these regions which have very less populations. So this is how we represent symbols in terms of size. Okay, so for this is basically very good for human perception, and when you look at size, it is logically matched to the ratio level. It is not used for any other purposes, but it is logically matched using a ratio. Map readers often have a trouble accurately estimating the data values, because it gives more of a qualitative data. It doesn't give you a quantitative data. Quantitative data is in the form of a range, so the it is more of qualitative data on or a range data that is represented here in the form of symbol size. Okay, there is map graphic symbols that are also represented as a shape. So varying geometrical shapes are best suited for indicating qualitative differences in the images. So shapes convey no overall impressions, but may be used to convey details. Okay, I explained you a good example of airport. Here for example, this is an example of airport in a Google map. Okay, if this is the airport and it is showing a symbol here, which is shape here, which is actually representing a flight or an aeroplane, or in a form of a point. So now that is the shape which is representing the most of the airports across the world. Okay, so that is the best way of informing anyone who is looking at the map. Symbol shape exists along a mimetic abstract continuum. Mimetic symbols appear to be mimic the feature they represent. For example, you may have looked at Google Maps. If you want to look at represented a restaurant, it represents in a form of you have a fork, you have a spoon, and you have a plate. So similarly, for every if you look at the hotels with lodging facility, you have a bed, you have a pillow. So these are the symbols which actually mimic the real phenomena. Okay, that is where the map symbol is extremely useful for, even for shapes. So that I explained about the airport here. So there is color hue. Color is divided into concept of hue, intensity and saturation. So colors are often coded to scales and used to indicate quantitative properties such as population density. Normally urban density, population density, or rainfall intensity, all of these are represented in colors which are often coded using hue, intensity and saturation. The use of color also helps in exploitation of common association. Okay, so that is the very important aspect, distinguishing aspect when you are using hue, intensity and saturation in terms of color. Color coding can be done using a hex system or an RGB system. Normally it is done in an RGB system. Okay, somewhere, because most of us understand RGB system, and so it is easier to interpret. It is normally done in RGB system, but you can always use an hex system, so that if someone is more convenient using that, you can use a hex system. Then you have color value, that is based on density. That is, variation in density is used mainly to illustrate ranked qualitative data. Please be careful here, it is only ranked data. We don't use just a qualitative data in terms of when you are looking at a color value in terms of density. Lightness and gray values are best suited for areas. Okay, gray levels must be divided into not more than 10 sections, lest neighboring sections will be mistaken for each other. So normally these are qualitative data which are ranked, which have very less sections, are used in terms of color value or density value. The higher the density gives a higher value, lower the density gives a lower value. So it is only with very less number of different sections, and maximum that people think that cartographers have still used as most probably 10 sections and not more than that. The maximum number of different objects that can be observed by sight alone without connecting to brain is only 4. So when you are when you have 10 sections, you have to connect to brain at least twice. Okay, so if you are trying to look at this kind of classification, then it is better to use either 4 or 5 kind of minimal classification in terms of density. Okay, that is about density. Then you have orientation. So this many a times people would have used in terms of a regular usage. So the differences in orientation refer to different points or line patterns that are best suited to illustrate quantitative differences. If you have seen some of those Google Maps which actually shows you the flyover versus your lower junction road, so or the city road, you can see that there is certain elevation difference in terms of representation of a your data towards the flyover. It is actually given a different I mean direction, so that you understand that you have to have a slight right or a slight left and move up. Okay, so such orientation is very important to discriminate two objects of the same nature, and thus it is very effective in representing the nominal data set rather than any of the qualitative and quantitative data set. So orientation is less suitable for any quantitative information, as it generally lacks inherent order. They don't follow any order, nor is any single direction emphasized over the other. We don't have emphasis, but it is just the representation that actually matters. That is why you need orientation kind of symbols. Now, when you look at selecting, so you have so many kinds of ways of representation. So for each you have understood now for what you use what kind of symbols, or what may be represented in what, so you what kind of symbol, so you have understood all of this aspect. But there, you, if you are trying to select map symbols, there are certain ways that you have to look at. For example, when you are looking at the classification code, NRSC has its own land use classification code that is for the Indian subcontinent. So we follow the NRSC color codes in order to do the classification, land use classification. Similarly, when you look at the other guidelines, you have select point lines or symbol areas. These guidelines appear to consider the final application of the map. That is the first aspect that we have already spoken about earlier, that what is the application of the map, who is the intended audience, that you have to look at it. Consider characteristics of the cartographic variables. So now, for example, if you are representing let's say the population, and you try to represent it in form of a symbols, it may not be very effective. Instead, if you represent it in a form of shape, as I explained earlier, it would be much easier representation and gives you much more flavors. Okay, for example, here this particular map is representing the urbanization possibilities. If I had represented more gradations here with 50, 51, 52, 53 to 100, then it is very difficult to interpret what color is representing and what is the probability of that particular region to grow. Okay, so that is exactly what I mean by when I have to use cartographic symbols. Okay, this is representing a modeled data of for Kolkata. When you are using symbols of equal impact to represent equally important variables only, okay, keep this in mind. Most of them, when they are representing, they make a mistake that if they have the equally important variables, they try to represent in different ways. So that leads to or is a very similar way, but that leads to a lot of confusion, and also it may not represent the real world phenomena, or it may not reach the intended audience. Use related symbols for related phenomena only. Don't pick up symbols as you like. If you like certain set of symbols, don't use it. Okay, but it is for the real world phenomena that you are representing, use only those symbols. It will be more effective. Consider visual phenomena, symmetrical symbols, for example, for roads, for railways, for airports, etc. Heat tradition. Mainly, for example, this is a tradition, basically a red which is actually representing a danger or a threshold, and a blue that is representing a sea or better usable region. So these standards, if we can use the traditional standards, then it is very easy to communicate whatever you are trying to put out as data to the end user and to the audience. Okay, so and when we look at typical map library, we have different set of symbols that you can use. If you go into your entire in QGIS, you will have huge amount of symbol libraries that you can always import and use it. For example, this is an ISRI style line developed by ISRI, which is representing different symbols. For example, this is your symbols for your line, where it is representing different quality and quantity of representation. Here is representing a polygon with different styles. So you can use these symbols in terms of representations, and this is a symbols that is used by QGIS. Along with these, So you have, for example, airports, you have ships, you have your north arrow, you have your car, you have your parking. So all of these symbols can be used in an effective way. You have your railways here. So this is a junction, whereas this is a moving track. You have a vehicular signal. So all of these symbols are representing the real world phenomena. So only thing is, use them more judiciously so that your map becomes more logical. Okay, so errors in what are the if someone asks you, okay, so this is what this is basic symbol selection that we have to do, but there are again errors in the usage of these symbols. One is in first of all is the usage of the cartographic variables. So how do you use all of these symbols? Then background color sometimes is too strong compared to that of the information present, so that has to be matched in many places. Most of the thing happens like this, so you have to be extremely careful. Excessive number of dissimilar themes presented, so don't use dissimilar themes, either have the same thematic representation for all the layers, so it will be more pleasing to the eyes, and even interpreting it is much easier. If there is no way of representing it in a similar lines, then only go for the different way of representation. Inadequate legends, so there are many places where their legends are inadequate. You may have missed certain piece of information. Please look at it very carefully. That is where the error comes as a part of cartographic. Even your map data, everything is ready, there may be errors in this. So you have to look at every part when you are preparing a map using the GIS systems. Okay, to summarize today's class, we have looked at what do you mean by visualization process in GIS to create visually more sensitive information that can be delivered to the user. Information transformation in terms of real world to maps, how do we convert it from real world to maps? We looked at cartographic symbols, we looked at graphic symbols like size, shape, color, hue, color value, color saturation and orientation. We looked at how do we select maps, map symbols basically. Then errors in cartography and selecting, how do we actually look at all of these aspects. So if we have understood this, then probably even creating a map and working on a map is much easier. So this is about how do you create cartographic information. Probably in the next week we will look at what do you mean by geographic positioning system. How do we use a geographic positioning, what is the theory behind geographic positioning. I would not go into the signal theory and how it works, what are the different methods of capturing it, but I would give you a brief idea about what do you mean by a geographic positioning system. So once I've that would be the first 3 or 4 lectures, and the last 1 or 2 lectures I would in the next week I would look at the QGIS software. I would give you an introduction to QGIS. Here I and my TAs together will give you an introduction to what do you mean by how what is a QGIS, how it was born, how it has evolved over a period of time, what are the tools available, and how you can utilize it, where you can download, etc. All of these aspects we will look at in the next set of classes in the next module. Thank you very much. Till then, have a nice time.